Welcome. This is the Advanced Drivetrain Unit Notes for Robotics 2. The learning goals for this unit, I want you to be able to explain the purpose of a differential gearbox. I want you to be able to calculate the mechanical advantage of a warm gear system. I want you to be able to calculate the mechanical advantage needed for a lifting system, specifically yours, if you have one. And I want you to be able to design for the turning torque and turning scrub in a drivetrain. All right, let's go ahead and get started with video 1 then. Gearboxes. Now in this animation you can see what's called a differential gearbox. Believe it or not, this is what is inside the back of most pickup trucks. In fact, probably all pickup trucks, or rear wheel drive cars. And the purpose is to allow each axis to turn independently from each other. We need this. If you have a four-wheeler and you go through your yard, you may notice that it tears up the grass when you make a turn. And it's not because you're purposely damaging the grass. It's because that there's just one axle in the back of that four-wheeler. And when it makes a turn, the inside wheels don't have to travel as far of a distance as the outside wheel. And what that means then is that that inside wheel is being forced to turn through the same distance as the outside wheel, and that causes you to tear up the grass even if you're just making a simple turn. Differential gearboxes fix that. And they do that using planetary gears. So in this first animation here, this first part right here is coming from the motor. And then these go to the wheel. So the motor is starting by, it's a crown gear, or a bevel, I should say a bevel gear. And we see that we first have this part turning here. And this is connected to these red planetary gears swiveling around here. And what that allows us to do then is as the car or as the motor turns the wheels, we can get independent motion because these planetary gears don't have to turn each gear at the same rate. A consequence of this, though, means that typically when you're driving, you only have power to one wheel at a time. Down here's another animation. I believe this is from the Lego Mindstorm, but it's still a differential gearbox. Now, notice I'll let this cycle through. So here you can see the axles turning independent. So this is going clockwise, this is going counterclockwise. Now they are forced to turn at the same time. If you ever have an electronic differential on a new car or truck, what that does is it locks the rear differential together, just like it is right now, and that forces both wheels to turn at the same speed, kind of like the four-wheeler example. And that gives you a little more oomph if you're stuck in some mud. Over here we can see a lot of differentials here, and I believe here on this VEX system. And this is a pretty complicated system. It looks cool. I'm going to have to build this. It looks like a lot of fun. But we have a differential gear system. So this first learning goal, the purpose of a differential gearbox, well, the purpose is to allow the wheels to turn at separate rates. That way you don't have to worry about scrub and the wheels hopping up and down when you're on a system. So here we have a picture of this. We have, what I like about this is it really goes through and describes all of the different parts. So, notice we got the sun gear, the planetary gears, we got a crown here, transmission, the driving pinion. It even gives us a rough size here. So this is a pretty nice diagram of what's going on in the back of a car, and what you can also do with a robot. All right, to the next topic, warm gears. This right here is what we call a warm gear. The teeth, or the spiral teeth on here, is what we call the warm wheel. because that gear kind of snakes its way up and around the cylinder. Now, what's kind of cool about worm gears is that they have a really, really high mechanical advantage, but they're only in one direction. You cannot use a worm gear to increase speed, not by itself. Now, here's how we can calculate the mechanical advantage. It's a pretty simple formula. It is going to be the number of teeth on the worm wheel divided by the number of teeth on the worm gear. This is unique. This means that it does not matter how many teeth are on the second spur gear. The worm gear does not care how many teeth are on that spur gear. Now, the number of teeth on a worm gear, because it's all one gear, is 1. So really, the mechanical advantage comes down to this. How cool is that? I believe on the VEX system, the individual worm gear segments, I believe they have 7 teeth on the worm wheel. So I believe their mechanical advantages are all 7, which is the same as a 12-tooth gear to an 84-tooth gear. All right, in this example here on the right, we can see how we have a motor with a worm gear attached to it. Now, something that we've experienced, but I haven't really mentioned in any notes, when the mechanical advantage is greater than 1, it becomes harder to backfeed. And what I mean by that is if you were to grab a hold of this wheel, you would not be able to turn it. This motor can turn the wheel very easily, but the wheel will not be able to turn that motor. The mechanical advantage is too high. So, in other words, it acts as a brake. So at the end of competitions, if you were to pick up a robot and you wanted to leave it elevated so that it doesn't fall down, use a worm gear. Now let's take a look at this picture here. This is a little more complicated. But essentially what we have is we have our worm gear and our spur gear right here. And then we have a series of 60 tooths to 12 tooths. And I'd like to take a moment and calculate the mechanical advantage of this system. So what we want to do, we want to remember that mechanical advantage is output divided by input. And let's say that this little worm wheel has 7 teeth on it. The mechanical advantage then would be 7 to 1 times 12 over 60 times 12 over 60. So do you guys see how it's output over input, output over input, output over input? And when you do this, you get a mechanical advantage of 0.28. Now, what this means then is that the system is actually built for speed instead of torque. You know, when we go through and do some of our math, the output torque equals the input torque times mechanical advantage. So if that were a 393 motor, the input torque of a 393 is 1.67 Newton meters. So we get 0.47 Newton meters of output torque. the output speed equals the input speed divided by the mechanical advantage. So for a 393 motor, that's going to be 100 RPM divided by 0.28. So the output speed will be 357 RPM. So this is one way we can use a worm gear for speed. But notice we had to use a compound gear system in front of it to accomplish that. That concludes video 1.